We're going to start by taking a look at the equipment for today's lab. You can clearly see that we have our track set up and that there are two spots where we have attached photo gates. So this is a photo gate. On the left-hand side, the photo gate will send out an infrared beam of light, and on the right-hand side, there's a detector for that beam of light. So when that beam of light is shining, the detector knows that it's shining. The photo gate is then attached to this cord and goes to this instrument called a LabQuest. So let me show you how the photo gate works. So we're going to take, I'm going to call it a flag, and we're going to put the flag in the photo gate. And when it passes through the photo gate will send a signal to the LabQuest. So let me back up and show that when the flag passes through the photo gate, you can see on the LabQuest that it says blocked. And as soon as the flag is all the way through, the LabQuest says unblocked. The LabQuest itself will then measure the amount of time that the photo gate is blocked. You can see here that the length of our flag is 5 centimeters, or 0.05 meters. So if we know the distance of our flag and how long it takes for this flag to pass through the photo gate, we know distance and time. We can then calculate, or the photo gate will calculate for us, the velocity that our flag passes through the photo gate. So I've turned the LabQuest on, and now we're going to press the green button and it's going to run. So now it's waiting for the cart, which we're going to send through. And then down here, we can record the velocity. That's going to be the velocity. So we're going to push our cart slowly through the photo gate. And you'll see we get a velocity in this case of 0.084. And now we're going to push it quickly through the photo gate. So please back it up. And now push it quickly through the photo gate. And this time, you'll see that we got a velocity of 0.39 meters per second. So much faster that second time. The LabQuest will also report the actual time that the gate is blocked. So we just pushed it through again and you saw the gate time change to 0.358 seconds. So now we know that the distance that the gate was blocked was 0.05 meters. We could divide that by 0.358 seconds and we would get our velocity, hopefully, of 1.39 meters per second. So let's confirm that our LabQuest is accurate. So the distance is 0.05 meters. And we're dividing that by, you have to read it off of here, dividing it by 0.358658. And when we do that, we get a velocity of 0.139. And our LabQuest is giving us a velocity, hang on, it's not, it dimmed, is giving us a velocity of 0.139. So they agreed. Here's the other equipment we're going to need. We're going to need a scale so that we can determine the mass of our cart and our flag together. We're going to need 2 carts, each with a flag. The flags sit in the carts like this. So as the carts pass through, the flag will block the infrared beam of the photo gate. So let me show you where we're ultimately going to record our data. It's on page 197, and here's our data table. The way this is organized is there's information for the red car, and there's information for the blue car. For each experiment, we're going to run 3 trials for the blue car and 3 trials for the red car. And we'll run 4 different experiments. In the first experiment, we're going to have no extra mass on our cars. So they will look like this. There's no extra mass. Both cars are just the mass of the cart and the flag alone. In our second experiment, we're going to put an extra mass onto the blue car, like so. And then we'll move that for the third experiment. We'll move that over to the red car. And then finally, for the fourth experiment, we'll have each car have 1 extra mass on it. So let's get the masses of our carts, flags, and the extra mass bar. So the first thing we'll get the mass of is the blue cart and its flag, which is about 260, almost 262 grams. And now we're going to, for some of those experiments, we're going to be adding the extra mass bar. So please put on 1 mass bar. So 1 mass bar is 254, not quite as heavy as the cart by itself, but will almost double the mass of our cart. All right, I want to show you the plunger on the cart. So you can see the plunger sticking out. We're going to put the cart on the track. We're going to push the plunger into the cart, and then there's a tiny little button that when we depress the button, the plunger comes shooting out. There it goes. So fast you didn't even see it come out. All right, I'm going to demonstrate now our setup. So you can see that we have our left-hand photo gate, and we have our right-hand photo gate, and then we have our 2 cars, red car and the blue car, and they are equal distance from the 2 photo gates. So hopefully I've got them lined up right in the middle, and they're touching so that when we set off the plunger, that plunger is going to be pushing on the red car. And of course, if Newton's third law is correct, the red car is also going to be pushing on the plunger. So let's give it a try. This is trial number 1 for no mass. The velocity for the red cart, 0.977 meters per second. The velocity for the blue cart, 0.961 meters per second. This is trial number 2 for no extra weight on our cars. The velocity of the red cart is 0.980 meters per second. The velocity of the blue cart is 0.966. So this is trial number 3 of no extra mass and therefore no extra weight on our carts. They moved a little bit, so we're going to put them back in position. velocity of the red cart is 0.982, and the velocity of the blue cart is 0.901. Both of those are meters per second. This is the setup for experiment number 2. This time the blue cart has the extra mass on it. That mass is actually 252.6 grams. The red cart will stay without an extra mass. So this is our second set of experiments, trial number 1. Yeah, a lot slower. The velocity of the red cart was 1.112, and the velocity of the blue cart was 0.519. This is trial number 2, when the blue car has 1 extra weight. The velocity of the red cart was 1.136 meters per second, and the velocity of the blue cart was 0.549 meters per second. Third trial, with the blue cart having 1 extra mass. The velocity of the red cart is 1.133 meters per second. The velocity of the blue cart was 0.548 meters per second. So for experiment number 3, we have now moved the mass to the red cart. It's the same mass, the 252.6 kilogram mass. So this is experiment number 3. This time the red car has the extra mass. Trial number 1. The velocity of the red cart is 0.575 meters per second, and the velocity of the blue cart is 1.110 meters per second. This is trial number 2 with the red cart and 1 mass. The velocity of the red cart is 0.581, and the velocity of the blue cart is 1.119. This is the third trial when the red cart has an extra mass. The velocity of the red cart is 0.568. The velocity of the blue cart is 1.105. For our fourth and final experiment, we're putting 1 extra mass on each cart. The red cart has the 252.6 and the blue cart has the 254.4. So nearly the same amount of mass has been added to each cart. So this is experiment number 4, trial number 1. The velocity of the red cart is 0.717, and the velocity of the blue cart is 0.682. Second trial of our fourth experiment, where each cart has an extra mass. The velocity of the red cart is 0.714, and the velocity of the blue cart is 0.695. So this is our third trial, where each cart has an extra mass. The velocity of the red cart is 0.707, and the velocity of the blue cart is 0.698 meters per second. And this concludes the data gathering portion of our lab. Yay! In case you missed any of your data, You can check it here. Here are the numbers for the red car. And here are the numbers for the blue car.